Hello everyone. Today we have this numerical question from aerodynamics. Let's read through the following question. An aircraft approaches to land at a speed of 40 meters per second. The 1/5 scale of model is tested dynamically with similar condition in a compressed air tunnel at 10 atmosphere. Assume temperature of air around the aircraft of the scale model is equal as it behaves. In this wind tunnel test, it is measured that the load on the air tail is subjected to impulsive fluctuation at a frequency of 20 cycles per second. Calculate the shedding frequency of the aircraft. So let's assume we have a dynamic similarity expression for this particular question. That is to say that the Reynolds number of the model of the aircraft being tested in the tunnel equals the full scale Reynolds number, that is the prototype. So therefore we have REM equals REP. And this expression can be transferred to this particular equation here, which is rho VDM over mu for the model and to the prototype, in which we can find our expression of Vm, that is the velocity of the model inside the wind tunnel, that gives us this Vm equation. From there we can slot in all our values, and we know that the velocity for the prototype is 40 meters per second. The size for the prototype is 5. The size for the model is 1. And the density expression for the model is 10 atmosphere. The density expression for the prototype is 1. And the shedding frequency for the model is 20 cycles per second. By slotting all these values into this equation, we find our model velocity to be 20 meters per second. From there, by using this particular equation, that is the frequency, the product of frequency to the size over the velocities for the model to the prototype, we can singularly find the expression for the frequency for the prototype, which gives us this equation. Then by slotting all the values into this particular equation, we find our shedding frequency for the aircraft at the full scale, which is the prototype, to be 8 cycles per second. That is WP equals 8 cycles per second. Thank you for staying tuned.